So just continuing from the last video, I want to give you a couple of examples using this concept, using power in our circuit. So if you go to the store and you want to buy a light bulb, you are going to see some kind of power rating on that light bulb. So you might go to the store, maybe you see one light bulb is 30 watts. So maybe one light bulb is 30 watts. Or another light bulb might say, I don't know, 60 watts. Or maybe another one might say 100 watts. So what does this actually mean? What is this? So what does this value mean when you see that on a light bulb? Does that mean that those light bulbs are going to consume that much power all the time? No, that does not mean that. So what does that mean? Well, in most houses, the amount of voltage that is supplied when you plug something into some kind of outlet, right? So you got the wall outlet here. The amount of voltage that is supplied in this thing is 120 volts. So this thing is going to give you 120 volts of potential when you plug something in. And we will eventually talk about how a device takes that 120 volts and reduces that amount of voltage for use. So when you plug your phone in, for example, to charge it, you probably don't want 120 volts. So we'll talk about how we actually reduce that voltage from the wall. But that rating, so let's say that we plug our light bulb in here. Okay, so we've got our light turned on. And so this number that we see on the box when we buy a light bulb, this is the amount of power that that light bulb will consume if connected to 120 volts. Okay, so if we have a 30-watt light bulb, that means that it is going to consume 30 watts of power if it's connected to 120 volts. Okay, so so kind of drawing our normal circuits here, let's just pretend that we have a 120 volt battery, for example, and we connect a 30-watt light bulb to it. Again, that just means that it's going to consume 30 watts of power. All right, so I have an example for you, and I encourage you to pause the video and try it for yourself, see if you can figure this out. But let's say we have two light bulbs. Let's say we have, so example, let's say we connect a 30, let's do a 60-watt light bulb, 60-watt light bulb, and let's say a 100-watt light bulb. Let's say we connect them, and we connect them in series to a battery, let's say with 9 volts, for example. We connect a 60-watt light bulb and a 100-watt light bulb in series. Let's say we connect them to some kind of power source where both of them are going to illuminate. We connect them in series, and the question will be, which light bulb is brightest? Okay, so the question is, which light bulb is the brightest? Okay, so again, in the last video, we said that it's not current necessarily that indicates brightness, but it's actually power, the amount of power consumed. Okay, which light bulb is the brightest? And also, remember we just now said that if a light bulb has this rating on the box, so if we grab a 100 light bulb and a 60-watt light bulb, that doesn't necessarily mean that they are consuming 100 watts all the time. Okay, so think about this question here. Are they are they the same brightness? Is the 60-watt brighter than the 100? Is the 100 brighter than the 60? Or is there not enough information to determine that in this problem? So try it on your own, and I'm going to provide the solution for you. Okay, so the way to think about this, all right, so if we write down some equations here, we know that the power consumed by a light bulb is going to be equal to the current going through that light bulb times the potential across that light bulb which is also equal to, we had a couple other equations here, it's also equal to I squared times the resistance of that light bulb. Or we could get rid of um, I for delta V over R, and it's also equal to delta V squared over R. Okay, so let's draw this circuit here. We have our battery, some kind of potential, right? It doesn't necessarily have to be a battery, but we're providing some kind of voltage to our circuit here. And the important thing is that the light bulbs are in series, okay? So we've got, let's just say, our 60-watt light bulb, and then we have, right after that, we have our 100 light bulb, 100-watt light bulb. And it really doesn't matter what order you put those in. 100-watt light bulb. Okay, which one will burn, which one will be brighter? So if any of them are brighter at all. So what we're looking at is which one has the highest amount of power consumed. Okay, and so the current going through this thing, the current going through each light bulb is the same. I is the same. Delta V is not necessarily the same. That depends on resistance, and so therefore resistance is not necessarily the same. Okay, so if we tried to use I delta V, we could do that, but we don't know delta V of either resistor. We could use I squared R. Again, we don't know the resistance yet. And so this equation is not so useful right now. So what we really need to do, I think, is we need to look at this equation right here. Power is equal to I squared R. And we need to determine which one is going to have a larger resistance. So the one with more resistance is going to have a higher amount of power. So which one has a higher resistance? And the way we can look at this is we can connect it to a 120 volt. We really don't even have to do that. Connect it to its own power source. So let's say this is our 60 watt light bulb, and then let's connect the other one by itself to the same voltage source. So let's just go ahead and call it 120 volts. This is also 120 volts. All right, and I want to know something about the resistance here. All right, so this is our 100-watt light bulb. Okay, the amount of power, let's just start with this circuit over here. The amount of power consumed by just my 60-watt light bulb is going to be the current going through the circuit times delta V, or we could say it's going to be, we could replace current with delta V over R. So this is equal to delta V squared over R of our, and I'm going to say resistance of our 60-watt light bulb. This circuit here, we can set up the same equation. Power is delta V. Both of them have the same delta V, but then it's going to have a different resistance, R of our 100-watt light bulb. Okay, which one is going to have the greatest amount of power in this case? In this case, it's the 100-watt light bulb, right? It's going to consume 100 watts, which is greater than 60. And so if this one has a greater amount of power, that must mean, since delta V is the same for both, that must mean that the resistance of a 100-watt light bulb is less than the resistance of a 60-watt light bulb. So what we're going to conclude here is that the resistance, and this is, no matter what, this is the case, the resistance of a 100-watt light bulb is going to be less than the resistance of a 60-watt light bulb. Okay, it's going to be less than the resistance of a 60-watt light bulb. And so what we can do is go back to this picture here where both of those are connected in series. In this case, delta V is not the same, only I is the same. The current going through the circuit is the same. And now we know something about the resistance in this case. We know that the resistance, and this is always the case, the resistance of the 100-watt light bulb is less than the resistance of the 60-watt light bulb. We just determined that. So then I can set up my power equation. I have P equals I delta V is equal to, and I'm going to replace delta V with I times R. So this is equal to I squared times R. Now, in this case, both of them have the same current going through it, and so the amount of power consumed only depends on the resistance, and the one with the greater resistance is going to have the greatest amount of power consumed. And this, again, this is because they are connected in series. And so since the resistor of the 60-watt light bulb is greater than the resistor of the 100-watt light bulb, that must mean that the power consumed by the 60-watt light bulb in this case is going to be higher, which means, so we can conclude that the brightness, or we'll just say that the 60-watt light bulb, the 60-watt light bulb is actually going to be brighter than, so it's brighter than the 100-watt light bulb. Okay, that's kind of counterintuitive if you ask me. Um, so what I want you to do, what I encourage you to do then, okay, is ask the same question. Which one of those two is brighter? But this time, connect them in parallel. All right, so this time, why don't you see what happens if you connect, let's say you connect these two in parallel. So maybe this time you've got the 100-watt light bulb and you're connecting it in parallel with the 60-watt light bulb. See which one is going to be brighter. And again, it's the amount of power consumed that will determine how bright the light bulb will be. So see if you can figure that one out on your own. And make sure you review this and you understand why in this case the 60-watt light bulb ended up being brighter. And if you want to check, I mean, if you have the ability to do this at home, that'd be great. But if not, if you go to there's all kinds of simulators that we've checked out, and you can test this idea out to see if it really works.